If your science notes look like a jumble of random symbols, don't worry. You're not alone. Chemistry can seem overwhelming at first, especially when you're faced with pages full of strange letters, numbers, and squiggly lines. But what if I told you there's a secret weapon that can help you make sense of it all? The periodic table is here to save the day. It's not just a colorful chart hanging on your classroom wall. It's actually the ultimate cheat sheet for understanding the building blocks of everything around us. Let's crack the code together. All right, picture this. The periodic table is like a giant organizer for all the elements, from the lightest, hydrogen, to the heavyweights like uranium. Imagine it as a map, guiding you through the world of chemistry, showing you where each element belongs and how they all connect. Each box on the table is packed with information. You'll see the element's symbol, which is usually 1 or 2 letters, its atomic number, and its atomic mass. The symbol is like a nickname for the element, while the atomic number tells you its place in the lineup. Think of the atomic number as an element's ID card. It tells you how many protons are in the nucleus. For example, hydrogen has just 1 proton, so its atomic number is 1. Oxygen has 8 protons, so its atomic number is 8. This number is what makes each element unique. The table is arranged so that similar elements line up in columns, called groups. Each group shares certain properties, almost like a family. For instance, elements in the same group often react in similar ways or have similar appearances. For example, all the elements in group 1, like sodium and potassium, are super-reactive metals. Drop them in water and you'll see some wild reactions. These elements are called alkali metals, and they're known for being soft, shiny, and eager to bond with other elements. On the other side, group 17 elements, known as halogens like chlorine and fluorine, are also highly reactive, but in a different way. They love to combine with metals to form salts. Think of table salt, which is sodium and chlorine together. Rows, called periods, show how the element's properties change as you move across. As you go from left to right, elements gradually shift from metallic to non-metallic, and their behaviors change too. It's like watching a transformation happen right before your eyes. At the far right, you'll find the noble gases like neon and argon. These elements are famous for being super stable. They don't like to react with anything, which is why neon signs can glow for years without changing. Ever noticed how metals are on the left and non-metals are on the right? That's not a coincidence. The table is designed to show you at a glance which elements are shiny, good at conducting electricity, or brittle and dull. And right in between, you'll find the metalloids, elements like silicon and boron. These are the in-betweeners, with properties of both metals and non-metals. Silicon, for example, is crucial for making computer chips. Oh, and those 2 rows at the bottom? That's the lanthanides and actinides, special elements that didn't quite fit up top. Lanthanides are used in things like powerful magnets and camera lenses, while actinides include elements like uranium, which is used in nuclear power. The periodic table wasn't always this organized. It took years of discovery and the genius of scientists like Dmitry Mendeleev, who first arranged the elements by their properties and left spaces for ones that hadn't even been discovered yet. But here's the cool part. By looking at where an element sits, you can predict how it'll behave, react, or even what color it might be. The table is like a crystal ball for chemists, helping you guess what will happen in experiments before you even start. So, next time you see the periodic table, don't panic. It's your best friend for science class. With a little practice, you'll be able to read it like a pro and unlock the secrets of chemistry. Stay curious and keep exploring. Remember, every great scientist started with a question and a sense of wonder, just like you.